Okay, picture this. You're sitting down, right, trying to get something done. Maybe pull some figures from a spreadsheet, search your company wiki for something, check a customer record, then maybe draft an email based on all that info.
Yeah, the everyday juggle.
Exactly. And you've got these incredibly powerful digital tools, but getting them to actually work together feels like, well, sometimes it feels like you're back in the early days of tech, trying to connect gadgets with totally different, incompatible ports.
Mm-hmm. The adapter nightmare.
Totally.
Yeah.
You're copying, pasting, flipping between tabs, fighting with different interfaces. It's kind of the digital version of that, that box full of old random cables you keep just in case. Every connection was this one-off custom mess before something like, say, USB came along.
That friction you're describing, that's exactly the problem that's become super obvious as AI language models have gotten so capable. We have these models that are frankly brilliant at understanding language, processing instructions, pulling together info they were trained on.
Yeah, they can write amazing stuff.
They can,
Yeah.
but they've historically been quite isolated. It's like that super smart consultant you hired, but you've basically locked them in a room. You can only slide paper documents under the door.
Right. They can
Yep.
just reach out.
Exactly. Getting them to actually do things in the real world. Search the live internet right now, access your specific up-to-the-minute files, update your calendar, talk to your cloud services. That's always been the really hard part.
And the way people try to connect those like isolated AI brains to the real world of tools and data has been, well, let's just say, not very elegant.
Less than ideal.
Every time you wanted an AI app or, an agent to talk to a new system, a different database, some API, it felt like building a completely custom bridge from scratch. Every single time.
Absolutely. The sources we're looking at today, they describe it as tedious and ad hoc. Developers had to write, custom code, special prompting, bespoke solutions for pretty much every single integration. Yeah. You had to figure out how to call that specific API, how to handle its unique data format, how to securely manage credentials just for that service, build safety checks specific to that interaction.
Because there was just no common language,
Yeah.
right? No standard way for the AI and the tool to shake hands. So adding a new skill meant a whole new chunk of development just for the connection piece.
Precisely. And it wasn't just inefficient to build. One of the developer intros we looked at calls it a maintenance nightmare.
Well, I can imagine.
Think about it. If one of those external APIs changed, even slightly, your custom integration just broke, poof. And if you wanted to add multiple tools you were building and then constantly trying to maintain all these fragile, separate connections, it was like every potential interaction needed its own connector, its own protocol, its own safety checks. Made it incredibly slow and complicated to actually scale up what AI could do.
Which brings us squarely to the heart of today's deep dive.
Yeah.
Because this collection of articles, research papers, developer notes you've shared, they're all pointing to something pretty significant, something designed to fix this exact fragmentation mess. It's called the Model Context Protocol, MCP for short. And the analogy that just keeps popping up everywhere, the Wikipedia dev intros, The Verge, is that MCP is basically designed to be the AI USB-C port.
That's the core idea, yeah. Instead of needing a unique custom adapter for every single external system, MCP offers this universal, standardized way for AI applications and agents, they call them the AI client, to discover, connect to, and interact with any external system or data source that speaks the same language that runs an MCP server.
So it creates a consistent
A
handshake.
consistent interface, exactly. For the AI to retrieve data and perform actions, it acts as a standardized framework, a kind of bridge between large language models, LLMs, and various databases, applications, or APIs.
Okay, so today we're going to unpack this. What is MCP, really? How does this AI USB port actually work under the hood? Why is this standardization such a big deal? Who's actually adopting it, and what kind of ecosystem is building up around it?
And crucially, what about the security side? Because connecting powerful AI to everything else, that raises some big questions.
Definitely. What are the significant security issues people are talking about? And, how is the community trying to tackle those potential risks? This deep dive is all about pulling out the most important insights from the material you've gathered on this really foundational new standard. Okay, let's dig in.
Let's do it.
So let's go a bit deeper on that why, that fragmentation problem you mentioned, tedious ad hoc maintenance nightmare. Can you paint a slightly clearer picture of what that actually felt like for someone trying to build a useful AI app?
Sure. Think about it from, a developer's shoes.
Yeah.
Say you're building an AI assistant. You want it to be able to read your user's documents from, I don't know, Dropbox maybe, and then update a task in Asana based on that.
Okay, pretty common scenario.
Right. But before MCP, you had to integrate the Dropbox API and the Asana API separately. These are totally different APIs. They have different ways to log in different authentication, different ways they structure their commands, their endpoints, different ways they format their requests and send back responses.
So 2 different languages to learn.
At least. You'd have to write custom code to handle, say, OAuth for Dropbox, then maybe deal with API keys for Asana. Then you write the specific HTTP calls for each service. Then you write more code to parse the unique JSON or sometimes even XML that each one sends back, trying to turn it into something the AI model can actually understand and use.
And you'd have to repeat that whole dance for every single service you wanted to connect.
Exactly. Every new tool, every different data source. Same complex custom integration process all over again. And the sources point out it wasn't just the coding, it required special prompting too. You often had to write really specific instructions telling the LLM how to interpret the output from a particular API because there was no standard format. It wasn't just inefficient to build, it was, like we said, a nightmare for maintenance. If Dropbox or Asana updated their API, which happens all the time, your custom code could just break. You'd have to go back, figure out what changed, rewrite your integration. This maintenance nightmare really limited how many tools and data sources AI could realistically connect to. It kept AI agents kind of isolated from the vast context and tools that could make them truly useful, as one source put it.
So the AI was smart inside its box, but getting it to reach outside in a scalable way was the real bottleneck. And that's exactly what MCP is designed to fix.
Oh, that's the core promise, yeah.
Yeah.
That AI USB-C analogy we keep mentioning from Wikipedia, the dev intro, the Verge, it's not just a catchy phrase, it really captures the technical goal. MCP provides that consistent interface.
One plug fits all, kind of.
Sort of. Instead of building a custom adapter for every service, you build to one standard protocol, MCP. So if an external service, like your company's ticketing system or some niche database, exposes its capabilities through an MCP server, well, then any AI application that runs an MCP client can theoretically connect and talk to it using that single standard mechanism.
Okay, that sounds like a huge step up.
Yeah.
So what are the really big wins here? What are the main benefits the sources highlight for this kind of standardization?
Yeah, there are several, and they're pretty compelling. The first big one is rapid tool integration. This is massive for scaling AI capabilities. If someone could be the company that makes the service, could be your internal IT team, could even be some open source contributor builds an MCP server for a service.
Like for Salesforce or Jira or something?
Exactly. Or even a really specific internal database. Once that MCP server exists, any MCP-compatible AI app can basically immediately gain that ability to interact with that system. You don't have to go back and rewrite the AI app's core logic every time you want to add a new tool.
So the AI app learns MCP once, and then it could potentially talk to anything else that also learned MCP.
Precisely. The developer intro calls this a huge win for automation. It's like having access to a constantly growing library of ready-made plugins that any AI can tap into just by finding the right MCP server.
So once a service puts up its MCP sign, it's open for business to any AI that speaks the language.
That's the idea. And that leads straight into the second major benefit, empowering autonomous agents. Think about building AI agents that can do complex things like multi-step tasks across different systems. Before MCP, that was incredibly hard because of all that custom integration work.
Right, the maintenance nightmare again.
Exactly. But with a standard way to access tools and data, AI agents are no longer limited to built-in knowledge. They can actively retrieve information or perform actions in multi-step workflows.
So this pushes AI beyond just like generating text based on its training data or maybe doing a quick ARG lookup.
Way beyond. The developer intro gives a great example. An AI agent could use an MCP tool to, say, check a customer's recent activity in your CRM, then use another MCP tool to draft and send a personalized follow-up email, and then use a third MCP tool to log that email interaction back into the CRM record.
Okay, wow. So query, draft, send, log, all automated.
All in one seamless chain, as they put it. That kind of capability, executing complex tasks across different software, that's what helps AI agents move closer to true autonomous task execution.
Sure.
It turns the AI from just an isolated brain that can talk into a versatile doer that can actually take actions for you.
Okay, faster integration, more capable agents. That makes sense. What about the poor developers building this stuff? Does it help them?
Definitely. That's the third benefit, reduce friction and setup. Because MCP provides that single universal interface, once your application supports the MCP standard, meaning it has an MCP client built in, it can connect to any number of services through a single mechanism. The MCP protocol itself, this dramatically reduces the manual setup needed for all those custom one-off jobs.
Less plumbing work.
A lot less. Development teams can focus on higher level logic, the AI's reasoning, the workflow design, instead of burning time reinventing connection code for the 10th time just because they want to talk to a different API. It replaces that whole mess of fragmented integrations with a simply more reliable single protocol.
So developers get to work on the more interesting AI parts, not the boring connection parts.
That's the goal. And that leads to benefit number 4. Consistency and interoperability. MCP enforces a consistent request-response format. It doesn't matter what the underlying service actually is. Could be a database, could be a file share, could be a web API. When the AI asks a tool to do something via MCP, or when it reads data from an MCP resource, the information gets exchanged in a predictable, uniform JSON structure.
So the AI doesn't have to guess how the data is going to look each time.
Exactly. It doesn't need custom parsers for every single service. Everything comes back in a standard format. This makes debugging way easier. It simplifies scaling things up. And this is important. It future-proofs your integration logic. If you decide to swap out the underlying AI model later, or maybe switch from one weather service provider to another, as long as both speak MCP, your core connection logic inside the AI app should largely stay the same.
Okay, and you mentioned it's not just for simple fetch and retrieve stuff. It supports more complex back and forth.
Yes, that's the 5th key benefit. Two-way context. MCP isn't designed just for simple one-off queries like, get me the weather. It actually supports maintaining context and ongoing dialogue between the AI model and the MCP server it's talking to.
How does that work?
Well, servers can provide more than just tools, those executable actions, and resources, the structured data. They can also offer prompts, which are described as reusable instruction templates. This means the AI can not only call an API, but also ingest reference data or follow complex workflows guided by the server.
So the server can kind of coach the AI through a complicated task.
Sort of, yeah. The developer intro source points out this is really valuable for more complex interactions. Imagine a coding assistant integrated into your IDE. The IDE's MCP server could provide prompts to guide the AI through a refactoring process, using specific tools and accessing specific code files, resources, in a structured way. Or an agent making a multi-step decision where the server provides guidance along the way.
That sounds way more sophisticated than just basic retrieval augmented generation, or ARGI, which is mostly about pulling in text snippets.
It's definitely an evolution. ARGI is great for giving AI access to information it wasn't trained on, right? But it's fundamentally passive retrieval. The AI gets the info, then reasons about it within its own context window. As one of the ARGI's papers notes, ARGI did not inherently allow models to perform active operations, such as modifying data or triggering workflows. MCP adds that crucial layer of standardized action and structured, potentially multi-turn interaction with external systems. It goes way beyond just looking things up.
Okay, so how does MCP stack up against other attempts we've seen to connect AI to the outside world, like ChatGPT plugins or things like LangChain?
Yeah, good question. It really builds on those earlier ideas, but aims for something more open and comprehensive. We started with those custom integrations, right? The brittle, one-off connectors, manual API key juggling, bespoke code for every service. MCP aims to replace all that with standardization.
Got it.
Then we saw things like ChatGPT plugins. The dev intro calls them an early step towards standardized tool use, which is fair. But they were proprietary, tied specifically to OpenAI's ecosystem.
Right, not universal.
Not universal. And they mostly focused on simpler one-shot calls like ask for something, get something back. And the authentication wasn't as standardized as what MCP is aiming for now. MCP is explicitly designed to be open and universal, working across different AI models and platforms, and supporting those richer two-way interactions we just talked about.
So plugins were maybe like a proprietary connector, whereas MCP wants to be the universal USB-C.
That's a pretty good analogy, yeah. Then you have things like LLM tool frameworks. LangChain is a big one. Microsoft Semantic Kernel is another. These are fantastic tools for developers building AI applications. They provide a consistent way for the developer to define tools in their application's code and chain them together in complex workflows.
Okay, so they help the developer manage the tools.
Exactly. But as the dev intro points out, these were largely developer-facing standards. The AI model itself wasn't necessarily aware of the LangChain standard. It was the developer's code, using the LangChain library, that knew how to call the tools defined within that application's code. MCP, by contrast, is designed as a model-facing standard.
What does model-facing mean here?
It means the AI model learns to output a standardized kind of message and intent, saying, I need to use a tool for X. The MMCP client then intercepts that standardized intent and can dynamically translate it into requests to discover and use tools provided by any MCP server it can find and connect to, even servers the original developer didn't explicitly code for.
Okay, I see the difference. So LangChain helps developers structure tool use inside their app, while MCP standardizes how the AI signals its need for a tool and how that request gets handled externally, allowing for dynamic discovery of tools out in the world.
Exactly. And they're not mutually exclusive. They actually complement each other well. The dev intro explains that frameworks like LangChain can easily integrate with MCP, using MCP servers as just another source of tools alongside tools defined locally in the code.
And what about OpenAI's function calling? How does that fit in?
That's also complementary. Function calling is essentially the mechanism by which OpenAI's models can output that structured JSON message describing the function or tool they want to call. MCP then takes that structured intent and handles the actual execution through its standardized client-server protocol. So you could say function calling handles the formatting of the AI's request, and MCP handles the standardized transmission and execution of that request with an external server.
Got it. So MCP is kind of layering on top of these previous concepts, aiming for an open universal protocol that simplifies integration, enables much more complex agent behavior, and standardizes things like discovery and interaction in a way that wasn't really done before.
That's the picture painted by the sources, an open model agnostic protocol, really designed for broad adoption.
Okay, we've definitely covered the why and the benefits. Let's get into the how a bit more. You mentioned this client-server setup and 3 core primitives. Can you walk us through the nuts and bolts of that structure?
Absolutely. So fundamentally, it's a client-server architecture. Think of it like browsing the web. Your web browser is the client, and the website server provides the content. In MCP, the AI-powered application, your chatbot, your IDE assistant, your complex agent, acts as the host and runs the MCP client.
Yeah.
That client is the piece that knows how to speak the MCP language, the protocol.
Okay, the AI app has the client.
Right. And then the external system, you want the AI to talk to Google Drive, your SQL database, Asana, whatever runs an MCP server. That server is responsible for exposing the capabilities of that external system using the MCP protocol.
So the server translates between MCP and the actual system's native language.
Precisely. The AI model itself doesn't talk directly to, say, the Google Drive API. Instead, the model figures out what it wants to do and sends its intent, often as one of those structured JSON outputs like function calling, to the MCP client running alongside it. The client takes that intent, translates it into a standard MCP request message, and sends it over the network to the appropriate MCP server, like the Google Drive MCP server.
Okay.
The server receives the standard MCP request. It then translates that request into actions for the actual underlying system, like making the correct Google Drive API call or running a specific SQL query. It performs the action, gets the result back from the underlying system, and then this is key, it formats the result back into the standardized JSON structure that MCP expects. It sends that standardized response back to the client.
And the client gives it back to the AI model.
Exactly. The client receives the standardized response and feeds the structured results back to the AI model, which can then process it and use it to, say, formulate an answer for the user or decide the next step in a workflow. That client-server layer acts as the crucial standardized intermediary.
Got it. And the communication between that client and server is organized around those 3 primitives you mentioned earlier: tools, resources, and prompts. Can you break those down again?
Yeah, these are like the core vocabulary of the MCP protocol. They define how the AI can interact with the world via an MCP server. First up, tools. The sources define these as executable functions. Basically, these are the actions or operations the AI can ask the external system to perform.
Like send email or query database.
Exactly. Or update CRM record, generate 3D model, run this code snippet, anything the server wants to allow the AI to do. The MCP client can find out which tools a server offers by sending a standard request called tools list. The server responds with a description of its available tools and what parameters they take.
Okay, so it can ask, what can you do?
Right. Then, when the AI model decides it needs to perform one of those actions, it signals that intent. The MCP client turns that intent into a tool call request, packages up any needed parameters, and sends it to the server. The server gets the tool call, executes the actual logic needed in the background, maybe calling an internal API, running some script, and then returns the result of that action, again in that standard JSON format, back to the client. The dev intro used the example of a weather server offering a get weather tool that takes location as a parameter.
So tools, actions. Got it. What about resources?
Resources are the second primitive. These are described as structured data streams. Think of these as any kind of data that the external system wants to make available for the AI to read or analyze.
Not actions, but information.
Precisely. It could be the content of files, documents, spreadsheets, code. It could be records pulled from a database, system logs, images, audio files, even maybe the current state of an application's UI, like a screen description. Anything the server can package up as data.
Okay, and how does the AI get hold of these resources?
Resources are identified using URIs, Uniform Resource Identifiers. It's similar conceptually to a web URL, but specific to MCP. It's an address for a piece of data managed by an MCP server. The sources show examples like file.pathtoMyDocument.txt or postgres.myDatabaseUser staplesred123, or even potentially screen.currentWindow. The server defines what these URIs mean and what data they point to.
And the data can be different types.
Yeah, the main types mentioned are text for things like code, logs, plain text documents, usually encoded as UTF-8, and binary for images, PDFs, audio clips, often encoded using base64 so they can travel inside the standard JSON messages.
So how does the client actually read one? Does it just ask for the URI?
Pretty much. The client can discover available resources, maybe by sending a resources list request, or by using URI templates provided by the server. To actually get the data, the client sends a resources read request, specifying the URI of the resource it wants. The server then fetches or generates that data and sends the content back, again, usually wrapped in that standard JSON structure. The sources mention a server might even return multiple resources at once, like listing files in a directory, or potentially support updates for resources that change over time, like streaming logs.
Okay, tools for actions, resources for data access. What was the third one? Prompts.
Right, prompts. These are described as reusable instruction templates for common workflows. This is a bit more abstract, but the idea is that the MCP server can provide the AI client with predefined templates or structured instructions for carrying out more complex multi-step tasks.
So not just offering a tool, but offering a recipe for using the tools and resources.
Exactly. That's a good way to put it. Instead of the AI having to figure out from scratch how to achieve a complex goal using the basic tools and resources, the server can offer a prompt that basically says, to achieve task X, first use tool A with these parameters, then read resource B using this URI, then use tool C. It allows the server to provide structured guidance for common or intricate workflows. The dev intro mentioned they allow the AI to follow complex workflows guided by the server.
Okay, that makes sense. Tools, resources, prompts, these are the building blocks. Can we maybe walk through that AWS knowledge base example you mentioned, see how it all fits together?
Yeah, that's a great practical example from the AWS blog. Let's trace it. Imagine a user asks their AI assistant, what's our quarterly IT security audit procedure?
Okay.
1. User asks the question, it goes to the LLM. 2. The LLM processes it, realizes, okay, this isn't in my general training data. This sounds like internal company knowledge. It decides it needs to use an external tool specifically, one for querying the company knowledge base.
Makes sense. It knows it needs outside help.
3. The LLM then outputs a structured tool use message. This is the AI signaling its intent to the MCP client. It basically says, I need to use the query knowledge bases tool. The query parameter should be, what's our quarterly IT security audit procedure? And maybe I should specify the IT department knowledge base.
So it formulates the request internally.
4. The MCP client running in the AI app catches this structured message. It translates it into a standard MCP protocol request specifically, a tool call request addressed to the MCP server responsible for the knowledge bases. The request body contains the tool name, query knowledge bases, and the parameters the LLM specified.
Standardizing the message.
5. The MCP client sends this tool call request over the network to the correct MCP server. In the AWS example, this is an MCP server specifically set up for Amazon Bedrock knowledge bases.
Okay, the request hits the server.
6. Now, this is where the magic of the MCP server happens. The AWS blog really highlights this. The server handles all the messy details. It securely authenticates to the underlying Bedrock knowledge base service. It takes the query parameter and performs the actual search against the company's private data stored there. It gets the results, maybe ranks them, and then crucially, it abstracts all that complexity away from the client.
So the client doesn't need to know how Bedrock works.
Not at all. The server handles talking to Bedrock, deals with its specific API, its data format, everything. Then it formats the useful results into the standard MCP JSON structure.
Okay.
7. The MCP server sends this standardized JSON response back to the MCP client. The example JSON in the AWS source shows it includes things like snippets of the relevant documents found, maybe a URI pointing to the full document, which should be an MCP resource URI, relevant scores, and potentially helpful metadata like which department the document belongs to or when it was last updated.
So structured, useful information.
8. Finally, the AI LLM receives this structured result back from the MCP client. Now it has the actual procedure details, the context from the metadata. It can synthesize this information and generate a coherent, natural language answer for the user, like summarizing the key phases of the audit procedure it found in the documents.
Wow. Okay, that step-by-step really clarifies it. The AI's thought, I need knowledge, gets translated by the client, the server does the heavy lifting and hides the complexity, and the structured result comes back for the AI to use. That's pretty slick.
It is, and the fact that the response comes back structured, potentially with those resource URIs for source documents, gives the AI much richer context to work with than just getting a blob of raw text back.
So this clearly solves a big technical problem. Is this just, a cool idea people are writing papers about?
Yeah.
Or is it actually gaining traction? Is anyone using MCP?
Oh, it's definitely gaining significant traction. That's one of the most striking things in the sources. And what's really notable is who is adopting it. You're seeing major industry players, even companies that are normally, fierce rivals, elaborating on this standard.
Really? Who are the big names the sources mention?
Well, first, it originated with Anthropic, the folks behind the Claude models. They developed the initial standard and are really pushing it. They offer pre-built MCP servers that work with their Claude desktop app, and they've put out open source connectors and implementations to encourage others to build too.
Okay, so the creators are leading the charge. Makes sense. Who else jumped on board?
A huge one is Microsoft. The Verge article we looked at was pretty blunt, saying Microsoft is embracing MCP in a big way. They're actually building native MCP support directly into the Windows operating system.
Into Windows itself, wow.
Yeah, it's part of a bigger strategy they have to reshape Windows for AI agents. They're even setting up something called a Windows AI Foundry.
What does putting it in the OS actually enable? Like, what could an AI do then?
Well, potentially. AI agents running on Windows could use MCP to interact directly with core OS functions and user data, think the file system, maybe desktop elements, system settings, assuming, of course, that Microsoft or others build MCP servers that expose those capabilities securely.
So an AI could, find a file for you without you having to browse.
Exactly. The Verge mentioned a demo where the Perplexity AI could query the Windows file system using an MCP server instead of the user manually searching or attaching files. Microsoft is also planning an MCP registry within Windows, aiming for it to be a secure, trustworthy source for discovering validated MCP servers. That trust piece is obviously huge. And they're weaving MCP into tools like Copilot Studio, too.
So Microsoft is really betting on MCP as a fundamental layer for AI agents on their platform. That sounds like a massive endorsement.
It really is. And then you have OpenAI. They're also listed as supporting MCP. Sources mention support in their agent SDK and API, so their models are being equipped to work with the standard too. As we talked about, their function calling sits really neatly with the MCP framework. The function call describes the intent. MCP handles the execution.
Okay, so the two biggest AI model companies, OpenAI and Anthropic, plus the dominant desktop OS provider, Microsoft, all adopting the same standard. That seems like a pretty big deal for interoperability.
It definitely points that way. And Google is also cited as embracing Anthropic's standard, adding another major AI player to the mix.
Wow. Anthropic, Microsoft, OpenAI, Google. That's basically all the key players in the AI model and platform space aligning here.
Pretty much. And it's not just the model and OS folks. Remember that AWS blog post. AWS has implemented an MCP server specifically for their Amazon Bedrock knowledge bases.
Right, the example we walked through.
Exactly. So customers using Bedrock can now expose their internal knowledge bases to any MCP-compatible AI app using that standard server. It solves challenges with traditional knowledge-based searching by providing MCP tools for structured querying and MCP resources for getting the content back, with nice features like configurable results, semantic re-ranking, data source filtering, all handled via the MCP standard.
So instead of every company building a custom integration for their Bedrock KB, they can just use the standard AWS MCP server.
That's the idea. And the adoption goes even broader. The sources list a whole range of other implementations, showing the versatility. Baidu Maps is mentioned, presumably for location queries or directions. Blender, the 3D software which suggests AI might use MCP to interact with 3D models or scenes.
Oh, that's interesting.
Yeah. Replit, the online coding environment probably for AI interacting with code files, running tests, debugging. Wix, the website builder. Even companies like Cloudflare, who could potentially host remote MCP servers. And back on the Microsoft side, they're integrating it into developer tools like Semantic Kernel and their Azure OpenAI services.
That's a really diverse list.
Yes.
It's not just enterprise data. It's development tools, creative software, consumer services.
It suggests the standard is flexible enough to handle a lot of different kinds of interactions. And the ecosystem is actively being built out to help developers jump in. The resources page mentions SDK's software development kits in a bunch of languages. C#, Java, Kotlin, Python, Ruby, Swift, TypeScript.
So easy starting points for developers.
Right. Plus example servers, example clients, quick start guides, tutorials. The ArcStaff paper even mentions platforms popping up specifically for generating and managing MCP servers. It all points to that collaborative open source approach that Anthropic and the others seem to be encouraging.
It definitely sounds like this is moving fast, from just an idea to a widely backed standard with a real ecosystem growing around it.
It really does seem to be. But with that speed and widespread adoption, especially when you're talking about connecting powerful AI systems to potentially critical external tools and sensitive data, security becomes absolutely paramount.
Right. And the sources spent a good chunk of time on security concerns. You mentioned earlier that the first versions had some issues with authentication.
Yes, that was a key weakness highlighted in the developer intro source. When MCP first came out, it lacked a standardized authentication mechanism. Early demos often worked by just running the server locally on the same machine as the client, which obviously doesn't scale. Or developers had to manually pass around API keys or tokens between the client and server.
Which sounds messy and insecure.
Totally. It's cumbersome, hard to manage safely when you have lots of connections, and just doesn't work well for remote or multi-user applications. The dev intro called this a notable limitation. It handicapped secure remote use cases and meant that AI clients couldn't safely connect to arbitrary servers on our own without a lot of manual setup and pre-sharing of secrets.
So the protocol for how to talk was there, but not a standard secure way to prove who was talking and what they were allowed to do.
Exactly, that was the big gap. But the community recognized how critical this was. As the dev intro states, work was done to bake OAuth-based authentication into MCP. They decided to embrace OAuth 2.0 plus SOAN-OJ, which is, the industry standard, a widely adopted, secure, scalable framework for handling delegated authorization.
And using a known standard like OAuth brings a lot of established security practices with it.
It really does. Building OAuth 2.0 plus into MCP brings several crucial security advantages. First, dynamic client registration. AI clients don't need to be manually set up on every single server beforehand. They can register themselves dynamically using standard OAuth procedures, which simplifies setup and management enormously.
Okay.
Second, automatic endpoint discovery. Clients can automatically find the necessary OAuth endpoints, like the authorization URL, the token URL that an MCP server provides. This cuts down on configuration errors and makes things more secure by preventing credentials from being sent to the wrong place.
Makes sense.
Third, and this is probably the biggest one, secure authorization and token management. Oath is all about granting specific permissions. The access tokens that the MCP client gets are tied to the specific user who authorized the connection and the specific scopes or permissions they agreed to.
So the AI only gets the keys to the doors the user explicitly opened.
Exactly. It enforces that critical security principle of least privilege. The AI can only access the data or perform the actions the user actually consented to. Plus, these tokens are typically short-lived, so even if one leaks, the window of exposure is limited. And fourth, scalable multi-user support. OAuth is inherently designed to handle lots of different users securely accessing resources, which is essential if MCP is going to work in enterprise or large-scale cloud environments. And beyond the basics, the ORIC paper on enterprise security points out that implementers are pushing for enhanced OAuth features too. Things like requiring strong authentication for the user initially, maybe multi-factor authentication, MFA. Using audience restrictions, so a token issued for server A literally cannot be used to talk to server B. Using sender-constrained tokens, which tie the token to the specific client, making stolen tokens much harder for an attacker to use. And of course, regular rotation of the keys used to sign these tokens. The dev intro mentions services like Stitch-connected apps are emerging to help developers implement the secure OAuth flow specifically for their MCP servers.
Okay, so layering a mature, robust standard like OAuth onto MCP seems like a really solid way to address that crucial initial security gap and build a foundation for trust.
That's definitely the intention. But, connecting powerful, potentially autonomous AI agents to a vast open ecosystem of external tools and data sources, it inevitably creates new kinds of security risks, or at least amplifies existing ones in new ways. And the research community is already digging into this.
What sort of new risks are specific to this kind of interconnected AI world?
The arXiv papers you shared go into quite a bit of detail here. They look at risk across the whole lifecycle of an MCP server, how it's built, how it runs, how it gets updated. One paper, arXiv 08623, lists some key threats that are particularly critical for enterprises. Things like tool poisoning. This is where an attacker modifies a tool on a server, maybe changes its description to trick the AI, or alters its actual behavior so it does something harmful when called.
Okay, malicious tools.
Right. Then data exfiltration. Using a compromised or maliciously designed tool to secretly steal sensitive data that the MCP server has access to. Command and control, C2, maybe using a compromised MCP server as a hidden channel to control malware elsewhere in a network. Yeah. Update mechanism, compromise injecting malware when the server gets updated. Identity and access control subversion, finding ways around the authentication or authorization to gain access you shouldn't have. Classic denial of service, .os attacks against servers, and just insecure configuration, exploiting mistakes in how a server or client is set up.
Those sound like serious, but maybe somewhat familiar, enterprise security concerns just applied to this new MCP layer.
Yeah.
But wasn't there also something more novel, something specific to how the AI chooses which tool to use?
Yes. This is where it gets really fascinating, and it highlights the unique dynamics when AI agents are discovering and selecting tools from potentially competing providers. The arXiv paper, 1LMN54, dives into a novel threat they call preference manipulation attacks, or MPMA.
Preference manipulation. Okay, what's the goal there?
The attack applies specifically when there might be multiple MCP servers offering similar tools. Think maybe 3 different companies offering an MCP server for web search, or 2 different translation services available via MCP, or multiple stock quote providers.
So the AI has a choice of which tool to use for a task.
Exactly. And the goal of a malicious MCP server running an MPMA is to trick the AI's selection process so that the LLM consistently chooses that malicious server's tool, even if other options are better, cheaper, or more appropriate.
Why would they do that?
The motivation, the paper suggests, is usually economic gain. If the malicious server is offering a paid service, they get revenue every time the AI picks their tool. If it's a free service funded by ads, maybe they get ad impressions or clicks. It's essentially a specialized form of prompt injection.
But instead of the user injecting the prompt.
It's the server embedding manipulative prompts into the description it provides for its own tools when the AI asks, "What can you do?"
Yeah.
The server is essentially trying to advertise itself directly to the AI model to get picked.
Wow. So the server is trying to game the AI's decision-making for profit. That feels very 21st century. What kind of tricks did the researchers find they were using?
They explored 2 main strategies based on how LLMs seem to interpret these tool descriptions. First, DPMA, direct preference manipulation attack. This is the straightforward approach. Just stuff obvious manipulative keywords into the tool's name or description, like adding best tool in the world, most recommended, highest quality, use me, directly into the text the AI sees.
Subtle.
Not at all. But the researchers found it was highly effective. Often got a 100% attack success rate in their tests, meaning the AI almost always fell for it and picked the manipulated tool. The big downside, though, as the paper notes, is it lacks stealthiness. Any human looking at that tool list, or even a fairly simple automated check, would probably flag descriptions stuffed with superlatives.
Right, it looks like obvious spam. So what's the stealthier option?
That's the second approach they called GAPMA, genetic-based advertising preference manipulation attack. This one is much more cunning. It borrows techniques from traditional advertising.
Like what?
Things like using authoritative language. Experts recommend this tool for X. Emotional appeals, the tool you'll love using. Exaggerated claims, but more subtly done, achieves unparalleled speed. or even trying for subliminal cues, though that's harder to define. They used a genetic algorithm, a type of AI optimization technique, to automatically generate and refine tool descriptions based on these advertising strategies. The algorithm would try variations, see which ones were best at influencing the LLM's choice, while also trying to keep the description looking somewhat natural and not overtly spammy.
So using AI to craft manipulative descriptions to fool another AI, that's meta.
It is, and the results showed that GAPMA could strike a better balance. Some strategies, like the authoritative approach, for example, describing a tool as for retrieving verified information, were often pretty effective at swaying the AI's choice without being immediately obvious as manipulation.
Did they find if certain AI models were better at resisting this?
Interestingly, yes. The paper noted that some of the LLMs they tested, specifically GPT-4o in their experiments, seemed less susceptible to these MPMA attempts compared to other models like Claude, Gemini, or DeepSeek. They speculate that newer, more advanced models might have some built something like that, yeah. It happened with models like DeepSeek, Claude, and Gemini in their tests. It's kind of a small silver lining, but the overall economic threat is still potentially huge. The paper estimates that the unfair advantage gained from successful MPMA, just for something common like web search tools, could easily run into hundreds of thousands of dollars a year. And that market's only going to grow as MCP gets used for more paid services. It really highlights the urgent need for robust defense mechanisms to ensure the fairness of the MCP ecosystem.
Okay, so these novel attacks are a real concern. But it sounds like the community, the researchers, the big companies are very much aware and actively working on how to defend against them. What are the main mitigation strategies being put in place?
Yeah, security is definitely not an afterthought here. It seems foundational. The research papers and articles like the one from The Verge stress that you need a comprehensive, multi-layered security approach. For big organizations using MCP, that RSIV paper, 08623, lays out a strategy based on established best practices. Things like secure containerization, running MCP servers in lockdown, isolated environments with minimal permissions and strict resource limits, host-based monitoring, using tools like ADR or HIDs on the machines running servers to watch for any suspicious activity, enforce rules, and check file integrity.
Standard enterprise security stuff.
Exactly, but applied specifically to these MCP components. Then the enhanced OAuth 2.0 Plus we discussed. Strong MFA, audience restriction, constrained tokens, key rotation, rigorous input-output validation and sanitization to prevent injection attacks and stop data leaks, secure logging integrated with SIEM systems for monitoring, automated policy enforcement for configuration, capability discovery controls so clients or platforms can restrict which servers an AI is even allowed to see or talk to, server authentication using cryptography to prove a server is who it claims to be, and maybe even tool validation frameworks to review and approve tool descriptions and behaviors.
So basically, treating MCP servers like any other critical piece of network infrastructure.
Precisely. And integrating all this with the company's existing security, stack their IAM systems, their data loss prevention tools, their secrets management.
And are the big players saying they'll actually do this?
They seem to be. Microsoft, for example, explicitly states a security-first commitment in that Verge article. They talk about treating the LLMs themselves as fundamentally untrusted components that need to interact through secured interfaces, which is the right security mindset. Their planned MCP registry on Windows is meant to be a secure, trustworthy source, implying some kind of vetting for listed servers. And by releasing a developer preview first, they're trying to get the community involved in hardening security before a mass rollout. They plan to have specific security controls and requirements for any server that wants to be on their official list.
Okay, that sounds promising. What about that other angle, balancing the power of these autonomous agents with making sure the user still feels in control? Especially if agents start taking actions on our behalf.
That's another critical piece, especially as this moves beyond enterprise use and into consumer apps. The Verge article mentioned Microsoft is actively considering UI controls to balance automation with user awareness consent.
Like those, are you sure, pop-ups?
Potentially something like that, yeah. Maybe similar to the user count control, UAC prompts in Windows. The system might pop up a notification or require explicit user confirmation before an AI agent uses an MCP tool to do something potentially sensitive, like deleting files, spending money, or accessing private data via a server. The goal is to give users transparency and a clear point of control, so they don't feel like the AI is just running wild.
So security isn't just about stopping bad guys. It's also about building user trust through transparency and control.
Absolutely. It's securing the pipes and the data, yes. But it's also about making sure the user feels confident and in charge of what the AI is doing through those pipes.
Okay, it's clear a lot of thought is going into the security side. Beyond that, what about developers who actually want to build things with MCP? Is there support available to help them create clients or servers?
Yeah, the ecosystem seems pretty active there, too. The sources mention a growing set of tools and resources. There's specific mention of debugging tools, like something called the MCP inspector. It's described as an interactive tool that lets developers see the actual MCP messages flying back and forth between a client and server.
Like looking under the hood.
Exactly. See what capabilities a server is advertising, manually try calling a tool, check the format of the responses. That kind of visibility is invaluable when you're trying to build or troubleshoot an integration.
I bet.
And besides specific tools, there are comprehensive guides, quick start tutorials, example code for setting up both clients and servers in all those different programming languages we mentioned earlier. That really helps lower the barrier for developers wanting to experiment or build real applications. One source even mentions simple ways to just check if your server is running correctly, like through the Claude desktop app interface.
And how does this tooling relate to the whole life cycle of managing an MCP server?
The ArcSIF paper on enterprise security touches on that the phases of creation, operation, and update. And it stresses that security has to be baked into each stage. During creation, you worry about secure coding practices, preventing malicious code injection. During operation, it's about secure configuration, monitoring, managing credentials safely. During updates, you need to ensure the update process itself is secure so an attacker can't sneak in changes or bypass authorization controls. The SDKs and tools are designed to help developers implement these secure practices throughout that lifecycle.
And this is all happening out in the open with community involvement.
Largely, yes. That open source aspect, pushed by Anthropic and others, seems key. Making the protocol spec and reference implementations open allows for more eyes on the code, more feedback, easier identification of potential vulnerabilities, and just generally helps the standard improve faster through community contribution and peer review. Plus, having SDKs in so many languages naturally encourages broader participation.
Okay, great. So let's try to quickly pull this all together. We've dived deep into MCP, the Model Context Protocol. It's really emerging as this standard AI USB-C port.
Right. A standardized way for AI models and agents to finally connect and interact effectively with all sorts of external systems, apps, databases, services, you name it.
And it directly tackles that huge fragmentation problem that made building versatile, truly autonomous AI agents so difficult and slow before. It gives structure to the interaction using that client-server model and those three core ideas: tools for actions, resources for data, and prompts for guidance.
Exactly. And it's not just theoretical. We're seeing really significant adoption. Anthropic, Microsoft, OpenAI, Google, AWS, the biggest names are backing it. Plus, there's this growing ecosystem of implementations across different fields, supported by a growing set of developer tools and resources.
But as with any powerful tech connecting things, especially connecting AI to sensitive systems, security is a massive consideration. We saw that early versions had authentication gaps, but the move to embrace the robust OAuth 2.0 Plus standard is providing a much more secure foundation.
Right. And researchers are actively identifying and analyzing the new kinds of risks this interconnected world creates, including those really novel preference manipulation attacks, where servers try to trick the AI into picking them.
But the crucial point there seems to be that the community and the big companies are taking these risks seriously. They're actively developing robust defenses, leveraging strong enterprise security practices, enhancing authentication, looking for ways to detect and mitigate those new manipulation tactics.
Absolutely. It's a fast-moving space with enormous potential, but that focus on building in security and trust from the ground up seems to be there in the discussions and the research we've looked at.
So when you think about what MCP really enables, this future where AI agents can just seamlessly discover and act across potentially millions of different apps and services for us, it completely changes the game for what AI can do in our digital lives, doesn't it?
It absolutely does. And as that vision gets closer, this world of autonomous agents making decisions about which tools to use, taking actions based on what they find through protocols like MCP, It brings up a really important question, I think, for all of us.
Which is?
As the users, how do we make sure we stay in control? How do we get real visibility into what our agents are doing? How do we grant permissions deliberately, maybe granularly? And ultimately, how do we build genuine trust in these increasingly capable, interconnected digital assistants acting on our behalf? What does our digital agency really look like in a world connected by MCP?
That's definitely a question that's going to become more and more relevant as this technology rolls out. Something for you to think about next time you interact with an AI. Knowing the potentially complex web of connections it might be navigating just beneath the surface, thanks to standards like MCP.